Hi everyone, Rapper here. So today I'm going to be making a quick video talking about improving matching online data collection using optical character recognition. Data collection has been a pretty important aspect of matching related events for quite some time. A number of different communities do this. The Pauper community does it. I know the Legacy community and Vintage communities will do this as well. But yeah, so a pretty big aspect of matching online gameplay. And I'm going to talk about ways that can be improved. So this is a project that I've worked on with Pete Bernius, and I wanted to kind of share it because I think it's really interesting, and there's some kind of cool problem solving that goes into it. This does involve some aspects of computer science and programming, but I will try to make this presentation more of a high-level overview. I'm not going to go too into the coding details or anything like that. But instead, I want to try to focus on the problem at hand and how we can kind of solve it. At the end of this presentation, I'll be showing the code and the bot that I wrote live, and yeah, just kind of showing how it works. I want to preface this by saying that um, I think there's a lot of cool things that can kind of go into this, and yeah, there's a lot to take away from it. So yeah, without further ado, let's kind of hop into it. So, what is Magic Online Data Collection? Well, the general idea is that after a high-level event, whether it's a challenge or a PTU, players will stay behind and collect the data. So they'll watch the replays and they'll also collect the following: usernames, records, standings, what decks people played, and then at the end of all of it, they'll take a picture of the final image and they screenshot it. So this is what one of those images looks like, and yeah, I would say it's a very nice image. But if you think about it, there's a lot going on here. Typically, when we collect data, we only look at the leftmost column. So we're collecting the usernames, the records, and then we're watching replays. Pretty simple. We're not collecting anything else. We do want to have data images like this, just for reference and for sort of logging and things like that. But really, it's only collected, you know, the left hand side, right? I want to note that this is all done manually. Unfortunately, you cannot copy paste this data, right? It would be awesome if you could just highlight everything here and paste it into a spreadsheet. That would be awesome, but that's not an option right now. You just cannot do that. So you have to enter it in manually, which is time consuming and not super fun. So once it's all said and done, this is what you get when you kind of finish collecting data. So this is one of the events that I worked on. This was a spreadsheet that I worked on. And yeah, you can see I'm collecting usernames, the archetype they played, the number of match wins, the number of match losses. And the nice part about this is once we collect all of the data, we're able to kind of, get more information from it. We're able to figure out what was the most popular archetype in that particular event. What was the win rate of that archetype? What was the meta percentage of that archetype? You can also parse more data from the full screenshot to figure out things like how does affinity do against hexproof, right? Or you can figure out, the matchups between various archetypes. So there's a ton of data that you can get, and it's really nice because it lets you figure out what deck should I be playing for the tournament. Is the metagame healthy, right? There's lots of questions that can be answered when you have access to this data. So with that being said, why do we even care? Well, for starters, it provides insight into the health of the metagame. If you think the metagame is unhealthy, you typically want to have data to kind of back that up, right? To some degree. And I think having all of the data here really does that, especially when we get it week after week. The other thing that's really nice is we get complete insight as opposed to only having limited data. Typically, Wizards will only publish the top 32 or the top 16, depending on the event, and I don't really like that. I like to kind of get all of the data, right? This past weekend, we had a proper PCQ that had over 200 players. If we only get the top 32, we're missing a lot of data. So the fact that people will stay behind and collect all of it is really nice because we get complete insight. And you probably use it without even realizing it. So, for example, I've seen a number of content creators write articles referencing this data, and yeah, you oftentimes will use it uh, without realizing it. And I think it's something that is really nice, and yes, it would be nice to kind of automate this process. So without further ado, I would like to thank all of the data collectors. So this is a community-run project. It's not required, but it's done, and I think they're underappreciated, right? Every week we have people who take the time to fill out this sheet and give us the data that we want, right? And people will oftentimes look at this data, they'll talk about it, they'll be able to kind of take away insight into the health of the metagame, what's popular, maybe, use that data to figure out what should I play for the next event, things like that. And I think, I want to give a big shout out specifically to people like Pete Proteus, who has done a ton of work in sort of starting this community run project and maintaining it. And yeah, just want to give a huge shout out to him because without him, I don't think we would have this. And yeah, I also want to give a big shout out to everyone who kind of takes the time every week to stay behind and collect all of the data. Without you, we wouldn't have this project. And yeah, really big shout outs to them. So with that being said, how can this be improved? Well, for starters, entry data sucks. I don't want to have to enter in usernames and match wins and match losses and all that by hand. If I could automate it, that would be great, right? If I could copy paste it, that would be awesome, but I cannot do that. So I have to enter it manually, and that kind of sucks. The only labor that should really go into it is watching the replays and figuring out what people were playing. If you can do that, then, you'll be in really good shape. So we can accomplish this with the use of optical character recognition. So what OCR is you upload an image that contains text, and then we use a machine learning model to basically take the text from that image and convert it into a text file. So that way you can actually copy, paste, and use the text in that text file. And this is a pretty common problem. This is not a new problem. This is, I would say, kind of a solved problem in the sense that OCR has been done in a number of different ways by a number of different groups of people. And yeah, it's a really useful piece of technology. If you probably have seen it used in some capacity, or it's been used without you realizing it, in some capacity somewhere. It's a very common piece of tech, and it's just very, very useful. And so that's what we're going to try and use here. So we'll take a picture of the standings, we'll upload it to the model, and we'll get a text file. So now I don't have to write down everyone's names. I can just give it a text file, and we're done. So with that being said, what OCR do I use? I happen to use Easy OCR. I really like this model. You can use things like SessRep, OCR Space, or various things from Google, Amazon, or Microsoft, but I really liked Easy OCR. I thought that the results that it gave were pretty good, and it also just gives you a lot of other things of other pieces of insight, such as where the location of the word is on the page, the confidence index, things like that. Just a nice model. I don't think it's better than anything else. I think, it just depends on your use case. I think certain models are really good for certain use cases, but for the one that I had, I really like GCOCR. So with that being said, what is the ideal workflow? Well, first off, whatever we happen to use, it needs to be easily accessible. So people need to be able to easily use this without having prior knowledge of what OCR is or anything that's going on in the background. It should really just be as simple as I give you an image and then you give me a text file. That's it. It also needs to be very accurate, right? Mistakes will happen if you ever worked in machine learning. Mistakes are going to happen. No model is ever going to be 100% accurate, but we want it to be really accurate. I'm talking 80 to 90%. I think that's a reasonable barrier. And if it does make a mistake, it would be really nice if it notified us about a mistake. The big takeaway here is just it needs to be extremely easy to use, and if it's not, then we should question if our current implementation is correct. But these are sort of the things that I was looking at when working on this, and this is sort of my ideal workflow. So let's talk about how we can accomplish that. So for starters, the proper data collection is currently done in the Haslett Commons Discord server. I have found that another community, I believe it's the Legacy Data Collection community, they do theirs in the Discord server as well. Discord is a very popular way to do sort of community-run projects, and yeah, you should make it a Discord bot. So here I have them upload an image. It will notify them that it will read the image, and then once it's done, it will return a CSV file. it will return an image highlighting what it was able to find, and it will return a Google sheet with that CSV file data in the spreadsheet, so you can copy and paste it to other spreadsheets if you need to. But yeah, so that's sort of how I make it easily accessible. You don't have to know how to use any OCR, tools. You don't have to go to another website. None of it. Give the bot an image, and it'll take care of the rest. So yeah, that's how I made it easily accessible. So while making it easily accessible, I think it's pretty easy to do. Making it very accurate is another kind of tricky problem. So this is a screenshot from OCR.space. It is a online OCR tool that you can use. They also have a API that's really nice. But basically, I'm just giving it an image, and then it's giving me a text file. Now, the problem with this is that the text file that it gives me is not going to always be perfect, right? And you can see here, for example, it thought that the number 0 was actually a capital letter O, and it thought that the letter L was actually the number 1. And to be fair, these are not unreasonable mistakes to make. In fact, depending on the text or the specific font, even humans will make these mistakes. So, I don't think you can expect it to be accurate 100% of the time, but at the same time, if it's constantly making mistakes like this, it's going to be kind of frustrating to have to work with this particular data set because then we have to go through it and manually check everything. And that kind of sucks. So it would be nice if we can improve the accuracy, and if it does make a mistake, it will tell us that it made a mistake. So that's where the next step kind of comes into play. So there's sort of two things when it comes to improving accuracy. You're going to do pre-processing to kind of help the model get better accuracy on the image that you're providing. And then once it's done and it gives you an output, you're going to do some post-processing on the output. So this involves correcting common errors. And we're going to do that by using existing data to correct the outputted data from the model. So this is kind of cheating, but it happens to work really well. And I'll kind of go into more detail in a little bit. So in terms of image pre-processing, there's a lot of things that you can do. And this mostly boiled down to trial and error for me. What I found though was that if you resize the image, so you take that, you know, list of names and results, and you resize it, it does better, right? It's really that simple. I should note that we're not doing the full image. I'll talk about why that is in a little bit, but for data collection, we only need the usernames and the particular results, right? Because if we get the entire list of people, it's already going to be in order from first to last, right? So you don't really have to include that data. It's redundant. And then the only other things you need are usernames and results, and then you can just watch the replays to figure out what archetype people were on, what deck state chose to play, right? So this pretty much gives you all the data except for the decks people played, and you'll collect that through replays. But yeah, this is all we're really doing is giving it an image like this. We're going to resize it and give it to the model. There's other things you can do, such as converting it to a grayscale image. You binarize an image where it's straight up black and white. There's only two colors, nothing else. There's lots of things you can do, but I found that just resizing it and giving it that tends to do the best. And so once we have done all of that pre-processing, we're going to look at the output. And you can see it's pretty okay. It's not too bad. It's gotten most of the names right. There are some mistakes that it's made here and there, but those are correctable. You can see it's made some issues like, O and 0, 1 and L, things like that. But yeah, it happens, and not too bad. And this can be corrected, and we'll talk about that in a little bit. But so far we've seen that you have a model, you adjust the image that you image to the model, and then once you give it the image, you get your output. So that's more or less how machine learning works in general, right? Once again, I'm vastly oversimplifying. I'm not a machine learning expert by any means, but uh, you have a model, you train your model, and then you give it input, it gives you output, right? And you typically want a model that's very accurate, but that is not always going to happen. The problem that we have here, and this is kind of a cool problem to kind of think about, is that if you have a model that you don't have access to, right? I'm not able to tweak any parameters of that model because it's not my model. And I don't want to make my own model because that would be extremely time consuming and difficult, and that's just you're over engineering for the problem at that point. Not to mention, I think you're not working smart, but you're just working hard at that point. How do we even go about improving accuracy, right? We figured out everything we can do to kind of improve the image to help the model, but if it's not getting like 80 or 90% based off that, what else is there left to do? Well, you cheat. So over the years, we have collected a ton of data from these events. We have a list of, I think, over 2,000 people who have played in these challenges, right? I mean, you know, as you collect data, right? I mean, every community has this data, right? So you just get all the data and you or a list of usernames. Um, you can use that existing data to kind of pattern match. So if the model gives you an output for a particular username, you can do kind of an autocorrect approach where you say, okay, I'm going to look at the list of all of the usernames that we have, and I'm going to see if it matches up to anything. If it's an identical match, we can assume that it got it right. But if there are no identical matches, but there's something that's really, really close, we can kind of change it to that one, right? And if there's multiple things that are really, really close, we pick the best one, and then we notify them that, hey, there were a number of names that it could have been, you might want to review it. And if there were no names that it was able to find, 'cause, maybe the bot messed up really badly, it'll tell you, hey, this is what I think it is, but you might want to check it. Another possibility there is that it's just a new user, so it couldn't match it up to anything. But, you know, after every event, we update the user list, it's more accurate over time. And this is kind of how we solve this problem now because we have an autocorrect built into our model. This is not really common in machine learning. This isn't really what you should be doing in machine learning, but for our particular use case, I think it works really, really well. And yeah, this sort of cheating approach, uh, happens to kind of solve our particular problem. So this is kind of a quick uh, I guess, image or graphic to kind of show how it works. But you take your image, you send it into the model, so that will process it. It gives you an output of a username, and then you take that and you do some post processing, and then ideally you'll match it to the correct username. With that being said, let's see it in action. All right, so here we are with the bot. First things first, let's kind of see how to use it. So let's type help, and we can see that the bot has a number of different commands. So there's one thing I want to talk about here real quick. I mentioned this earlier, is that it doesn't read full images. So you can see here, read full is currently in the works. The problem with this is that really, really large images tend to be very difficult for OCR, right? Once again, I'm not an expert, so if you know of a way to make this work, feel free to let me know. But I found that no matter what model I ended up using, if the image was really, really big, the model got kind of overwhelmed, so to speak. And what ended up happening was it either would be very inaccurate, miss pieces of information, or if I was using an API, sometimes it would time out. So it's not great, and you have to kind of do it piecemeal, which is why typically what I end up doing is I just do like that one column. So instead of doing the giant image that I showed at the beginning, we just get the names and the ratings. I should note that for really big events for like 200 plus people, you should probably break it down. I found that, the bot can handle images that are around, I would say 60 people. It can do that pretty well. But when you start going over 100, it starts to kind of get difficult. And that's just because you have a really, really big image. And, it's really, really kind of tall and narrow, and for some reason that is difficult. I can't really give you a reason as to why or a solution, but there's something to let you know. That's still a problem that I have yet to solve, but that's how it is. But we have to kind of get back to the bot. We have read full, help, and code. So kind of tells you, for example, if you want to see the source code, you can type code, and it will link the source code right here. It's all public. You can do what you want. If you want to, take my repo and clone it to your machine, or make your own repo off of it, go for it, right? I'm making it public for a reason. I want more people to work on it, and to make it as good as it can be, right? Have, over the years, I have benefited greatly from the open source community, so this is kind of my way of giving back. So I'm a huge fan of open source code and open source projects, so yeah. And I think the code is pretty good. I try to make it as good as I could. Um, I don't want to get too technical into the code, but it's written in Python, and I'm using Flake 8 for style enforcements and things like that. But yeah, I think it's okay. I try to make it as simple and approachable as possible. But yeah, so all the code for the bot is in here. Now, if we want to actually read an image, let's grab an image real quick. So we can scroll up here. Let's look at this image, right? This is an image that we have, so we can kind of see it. It just has the usernames and the standings. And we can copy this image, and let's read it, right? So we can type read, and then we paste in the image like that, and press enter. And you can see it will say success, your image will be read, please wait. So what's going on here is that the bot is reading my image, pulling up the model in the background, and it's parsing that image. Um, the other thing that it's doing is once it's done, and this takes some time because I'm running it locally right now, but in the future I'll have it hosted somewhere where it will be on a better server instead of my laptop. It's a little old, but it'll be in a probably a better hardware environment than where it's at now. It should be a little bit faster, right? But in the meantime, while we're waiting, what it also does is it will, once it's done, it'll spit out an image showing everything it was able to find. It will spit out a CSV file with all of the data, and it will give you a Google Sheet with the CSV file in it, so you can copy and paste it to other Google Sheets. I found that people typically tend to store all of this data within Google Sheets, so it's kind of nice to have it in here so you can just copy and paste it in between. I should note that currently how the logic works is the Google Sheet is sort of treated as a whiteboard, meaning that what kind of goes on is every time you run this, it will delete everything in the sheet and upload it with new data, right? So we'll see here, it's done, and we can kind of open the Google Sheet to add in a full kind of picture of all the data. So here it just have it called as MTGO data holder, and yeah, you can kind of access the sheet, which is really, really nice. And so here you can see it has the usernames. It has a blank row here because this is where you'll put your archetype. It has the number of match wins, the number of match losses, and then over here it has a comment. And what this is doing is it's telling you what the bot did. So if there's nothing, it means it got it right. The bot outputted that name, and it checks the list of names that we have in our user list, and it was able to find an identical match, meaning that it is very, very, very unlikely that it got it wrong. Because the bot would have had to get the wrong name, which is an existing name, which is not a very common thing, right? And so, if it doesn't have it common, it's probably right. If it has the word check, what it means is that it was not able to find any names that were in our list of users, so you might want to review it, because maybe the bot got it really wrong. And this is a great one, for example, because it's called Francesco. I believe it's just Francesco Poo. It's kind of a funny name. But you can see here the bot messed up, right? It got it into two blocks, right? And so when it tried it, it got the name wrong. So it's telling you, hey, I screwed up. You might want to check it. The other thing is sometimes the bot will get it wrong, but it will be able to correct itself. So here we have Paulo Brawl underscore BR. If you look at this, well, okay, let's go here, right? So the green box is kind of removing some information. So there is an underscore here, right? But when the image highlighted this, what did it think it was? Well, it thought it was Paulo Brawl BR, one word, when in reality it missed the underscore. So the bot was smart enough to correct this, right? So actually, in our post-processing, we were able to correct it, right? And you can see it's doing this for a number of names, and that's really nice because it really helps improve the accuracy, right? So common mistakes are missing underscores, I's and L's, or, the number one. This one was pretty close to that. It actually got the wrong name. The bot thought this one was more likely, And it turns out it was actually this one, which is why I had the word mix, as I'm telling you, hey, you should review this. It could be one of these two. It might have hit the wrong one. In this case, it did, but it's okay. It notified you, right? We can see here that the name, I believe, was Zodiac, and it got the wrong one, right? It thought it was Zodiac Set. So, made a mistake, but it still notified you that it could be this one, so you can review it and fix it, right? And yeah, I mean, typically when it has the word fix, it means that it's probably right. I would say that the main things to look at are set and mix. Those are the ones where it's definitely wrong or it has potential to be wrong. There is also a possibility that it's just a new user that the bot has not seen before. So this is a very creative username. If we look at this, we can see that it actually got it right. Um, no mistakes, but it just hasn't seen the username before. So we need to update the user list after this. But yeah, it's not too bad. Just to show that this is not a fluke, we can look for um, another image. So we'll keep going up. So here's another image. Let's open this one up. This was about, I believe, 60 to 70 people, but this was a proper challenge which has around 70 to 80 people. I guess 60 to 80 people, roughly. But yeah, this was all the people in that event, right? So, yeah, it's pretty simple. So let's copy this, and let's try this one, right? We can type read, and then paste this in, and it'll read that, right? So you can have it read multiple images, and it's, you know, obviously, it'll always override the spreadsheet, so, you might wanna copy the server before you call it again, but, yeah, you can do it, any image you want, right? And what's nice about it is if you accidentally override it, you still have a CSV. So it's not like this data is gone forever, right? I have the CSV there for a reason, which is that the Google Sheet gets erased or something. You still have the CSV, right? So yeah, that's really nice. And so it's running, right? It takes some time, right? We're running on an old laptop, but yeah, it's really nice. It's if you look at I believe the percentages from the first one. So if we scroll down here and we count, I believe this had 61 people in it. If we only look at the chat, we have one, two, three, four. I'm gonna include mixed, right? Five, six, seven, eight, nine. 10, right? I think it's 10. I might have missed one, but there's like 61 people here and it got 10 wrong. So that's a little over 80%. It's like 80, 82-ish percent, right? Not bad, right? 82% accuracy is not bad. And it tells you when it thinks it got something wrong, right? And it's also correcting mistakes. So it's like, I think this is a pretty good spot, right? So if we look at this, right? If we look at this image, right, you can see that this is loading, right? So it has to update the sheet. But if we look at this, right, we can pull this up real quick. This is what we uploaded, and you can see it did pretty good, right? And even got the underscore for part of this name, which is really cool. Um, yeah, I mean it's doing really good, right? I mean it split this name up, but let's look at the spreadsheet, right? It had to load; it's taking some time. Um, If we how many things got wrong, right? 1, 2. Yeah, 2 things wrong. 2 things wrong. Out of how many people? How many people? So that's like a 97% accuracy. So it's getting between 80% accuracy on the low end to like upper 90 on the high end. I think that's pretty impressive, right? And it's able to fix mistakes. So that's pretty cool. It just looks interesting to you and you're part of the proper community, it is available, so you don't have to like download it or anything like that. But if you know are interested in this type of stuff and you like to code, yeah, feel free to pull it, mess around with it, see what you can do. Um, if you're in the other communities that do data collection and you're interested, you can reach out. I'm on Twitter, I'm on Discord, I'm on YouTube, so I'm available. But yeah, I think this was a really cool project. I learned a lot. I would like to give a big shout out once again to Pete Courteous. He also helped work on this code, and he's just done a lot in terms of data collection over the years. So once again, just big shout outs to him. Part of the code actually here was worked on with him. Like he played a big role in fixing some pretty critical bugs. So I want to give a big shout out to him. But yeah, overall, really really impressed with this bot, and yeah. Thank you for watching. That's really all I have to say. This is kind of a different video, but I thought it was a sweet project. I learned a lot, and yeah, I'll see you guys next time.